Hello, right. We are going to be taking a look at linear graphs today. We're going to be looking at equations, we're going to be looking at, graphs, gradients, y-intercepts, a little bit of everything. But I'm going to be cutting this video off at a particular point where I think that this goes beyond the kind of, crossover period and starts becoming that bit more challenging. But I'm going to try and take it as far as I can within the realms of doability. Okay. And the first thing that we need to be sure on are what everything means. Okay. And when we're thinking about what everything means, we need to know what our definitions are. Okay. So the gradient is another word for steepness, okay? And so we define steepness as being how far we have to travel up or down for every 1 unit that we would have to travel across, okay? So how far we travel up or down for every 1 unit we travel across. Okay, and thinking about where we've seen these ideas before, I've seen people thinking about their gradients using tables like we use for proportion. So if we were going 6 units up, but we were going 4 units across, this wouldn't do me for knowing a gradient. I would need to know how many I'd need to go up for every 1 unit I go across. Okay, so going from 4 to 1, we would have to divide by 4. We'd have to divide by 4 over here, so that would be our actual gradient. Because for 1 unit we're going across, we'd have to go up by 6 over 4, or like 1.5 even. But sometimes this definition isn't very helpful because looking at graphs can be very misleading. They might not be drawn very accurately. So another way that we can do this is thinking of change in y divided by change in x, or rise over run. Okay, this is probably the most common way that people remember what a gradient is. And you can think, change in y, your y direction in a graph is your vertical. That's how much you go up. Your change in x in a graph is your horizontal, so that's how much you go across. And you can see here we've done how much we've gone up divided by how much we went across, which is equal to our gradient. Okay. So you need to be able to remember how to work out the gradient. I would suggest that this is probably the easiest way to do that. Some other things. Parallel lines have the same gradient. So it doesn't matter what else is going on. If you've got the same gradient, those are parallel lines. And this one's a bit more tricky to work with, but perpendicular lines will have negative reciprocal gradients. And I'm not going to be touching on that in this video, but I will make another one which does touch on this topic. Okay, so this bit here in the middle, this is definitely what we need to know. But we also need to be able to put it into practice. We could be asked to find the rate at which something changes, and if we are after a rate at which something changes, we are after a gradient. Okay, that might be worth actually kind of acknowledging that if we're talking about rates, we're talking about gradients. Okay, that is important. So let's take a look at just a quick example of doing this. Okay. So we had our way of knowing the gradient, which is change in y divided by change in x. Now, if I look at this one here, I've gone up 1, 2, 3, 4, 5, 6, 7. So I've gone up by 7. But I've gone across 1, 2, 3, 3.5? It's hard to tell. So maybe change in y divided by change in x won't be such a good one for this. However, what I can tell is that for every 1 unit that I go across, I'm having to go up 2 units. Okay, we can see here 1 unit across, 2 units up. Okay, so for every 1 unit I go across, I go 2 units up. Our gradient equals 2. And often we will write that m is the letter for our gradient, and we'll explain why in a second. Now, let's try and use, the same trick for this middle one. If I were to go 1 unit across, I'm going 1 and 1.5. Again, not that easy to tell. So maybe for this one, my change in y divided by change in x might be slightly easier. Let's have a look. We've gone up 1, 2, 3, 4, 5, 6, 7. We've gone up by 7. And how much did we go across? We went 1, 2, 3, 4, 5. Change in y divided by change in x. So we would divide by 5. It gives us a gradient of 7 over 5, or 1.4? 1.4. Okay. And you can see we've gone how much we've gone up divided by how much we went across. This line here, again, if I were to go just 1 unit across, I can't even tell what that is going to be. So we'll do our change in y divided by change in x again. Okay, so I'm going to just get my up and across. So in this case, I've gone down. So this is just going to be a negative number. We've gone down 1, 2, so negative 2. We've gone across 1, 2, 3, 4, 5, 6, 7, 8, 9. And then just as before, we want to know for 1 unit we go across. So I'm going to have to divide by 9, change in y divided by change in x. So we're going to have our gradient to be negative 2/9. And if I'm being honest, fractions make perfectly good gradients. And in A-level, AS level, further maths, anything, using fractions can sometimes be just that little bit easier to work with. So if you're considering going further on, get in the habit of writing some fractions. So that is understanding how to work out the gradient, or the rate that something changes. Okay, gradients are always talking about rates. But we might not always have a grid. Okay, I know that's kind of like going, bah, but what if? We might not have grids. Okay, we might just be given 2 coordinates. And just like we saw in some of our lessons earlier, a couple of weeks ago, for when this video comes up, always remember that your coordinates comes in x and y pairs, okay? And that will make it really easy for us to see when we've got a change in y divided by a change in x. Sorry everybody, just 1 second. There we go, that's much better. Hopefully that'll stop me from getting too loud. Right. So, again, change in y divided by change in x. How much we go up divided by how much we go across. Now, up is relating with my y numbers, so I've gone from 5 to 11, which is going up by 6. Going across, I've gone from 2 to 5, which is across by 3. We want to know how much we go up for every 1 unit we go across. 6 divided by 3 is 2, so our gradient is 2. Okay? And again, change in y, 6 divided by change in x, 3. 6 divided by 3 is 2. So even when we've got just 2 coordinates, we can then work out what our gradient is going to be. What we can't do is we can't work out a gradient when we've only been given 1 point. We must have 2, even if that second point comes from like a y-intercept. Okay, looking at our graph. What we might have to do is to work out what a y-intercept will be. Okay, and a y-intercept is like the equivalent of like a standing rate, okay, or a standing cost. Okay, so like you might pay £10 to access a service, and then you might have to pay an extra £3 per hour. The £3 per hour would be like your gradient, because that's the rate. And the £10 starting fee would be like your y-intercept. That would be the place that where you start. Okay. So what we're going to take a look now is the equation of a straight line, which hopefully you can remember. If not, you're going to need to be able to remember it. And how we can get an equation of a straight line from various degrees of information. Okay, this is the form of a straight line equation. Okay, y equals mx plus c. You need to know that. You need to know that. M is our gradient, our change in y divided by change in x, or how many we go up for every 1 unit we go across. And the c at the end, that is our y-intercept, or our y value when x is equal to 0. Okay. Now, if we are looking at a graph and we can see where the y-intercept is, then we can just say that that number at the end must be equal to a thing. But if we have the scenario like we have over here, where we can't see where the y-intercept is, and it would be unreasonable for me to extend the line and draw like a grid around it, because that would be silly. I'm actually going to have to use the information that I've been given to work out what this y-intercept will be. Okay. So, just to show what I mean, we know what the gradient is. We've already worked that out. Is our change in y divided by our change in x. And that must mean that this equation, so far, will be y equals 2x plus c. Okay, and that c is a number that I just do not know what it is yet. Okay. So what I'm going to have to do is I'm going to have to use a coordinate. Okay, and we will have done this in other points as well. We will have done this when dealing with quadratics a little bit. We will have done this when dealing with some of the more complicated circle-y theorem questions. But yeah, we will have done this before. And it doesn't matter which coordinate I use. Okay. So I'm going to use the 1, 2, 5. just because I can. So this means that y is going to be 5, x is going to be 2. I've got 5 is equal to 2 lots of 2 plus some extra number, or 5 is 4 plus something. And it doesn't take a genius at this point to realise that that c has got to be equal to 1. So that means that the equation of this line that connects those 2 points is going to be y equals 2x plus 1. And that is our equation. Okay, so knowing what your gradient is, what your rate is, and any other point will help you figure out what your y-intercept will be, or what your starting value will be. Okay, so knowing those 2 bits of information, very, very helpful for establishing an equation. Okay, and if you have an equation, like we saw when we were doing our proportion work, that means that we can substitute in any value to find out any other value. So now I could say, well, what's y equal to if x equals 54? Or what is x equal to if y equals 10? Okay, and we can do anything like that. So, knowing that equation, very, very important. Knowing our gradient, very important. Or, and being able to find our y-intercept so that we can form our equation. Now, the limit to this, it extends quite far, far further than what I would like to do within this single video. But where I'm going to end this now is by kind of just showing you how that translates to if you're looking at a actual graph. Okay, someone's given you a graph of something, and for some reason we need to know the equation of the line. Okay, so there are 2 examples here. If you're feeling pretty confident with things, you might want to pause at this point and try finding the equation of those lines yourself. If you're not feeling so confident, you might want to watch me do the one on the left so that you can try the one on the right. But either way, I'll give you a moment to pause just for now. I'll give you 5 seconds. Okay, so I'm going to go through the first one. We need to know what the equation of our straight line will be in the form of. It'll be in the form y equals mx plus c, where m is our gradient and c is our y-intercept. Now, good news for us is that we've got a nicely drawn graph on a grid and we can see exactly where the y-intercept is. The y-intercept is at 3, so I know that c is equal to 3. I just got that from the graph. Okay, I didn't have to substitute any coordinates in or anything like that. I could just go, it's right there. The gradient, however, I'm going to need to be a little bit more careful for. Okay, now remember our gradient, change in y divided by change in x, or for every 1 unit we go across, how much do we go up? Now, for looking at this, I can actually see this quite nicely. If I pick a point, there we go, and I go 1 unit across, I have to go 2 whole units up. So my gradient for this should be 2, because for every 1 unit I have to go across, I have to go 2 units up. If you weren't sure about that because you didn't trust the graph, you could say, okay, if I pick this point here and let's say this point up here at the very top, where I'll put a little more black dot over here, I can see that I'd have to go 1, 2, 3 units across, so from -1 to 2. And I'd have to go 1, 2, 3, 4, 5, 6 units up. And 6 divided by 3 is 2. So we get a gradient of 2 either way. Our equation for the straight line would be y equals 2x plus 3. Okay. Now, if we were thinking about the blue area here is all the stuff which is upwards of that line. Okay, and if we're heading upwards of that line, we must be heading for things that are bigger. So this line actually shows us, or this area shows us the stuff where y is greater than 2x plus 3. Okay, but knowing what the line equation is will help you figure out what the area should be. Okay, now if you want to have a go at the one on the right, you've got 5 seconds to pause now. Okay, so the one on the right, we're going to start off by doing exactly the same thing. We need to know the equation of our straight line. This time I'm going to do my gradient first, so I'm going to pick a point. If I go 1 unit across, I'm having to go 2 whole units down. And it's nice and clear on this one. It goes through that point there. So for every 1 unit across, I'm having to go 2 units down. So I know that m is -2, and it's -2 because we're heading down. If I follow my line to the y-intercept, which is where I've put the square, we can see that square is at -2. So my y-intercept, c, is also -2. My equation for my straight line here, for the line would be y equals -2x. Now instead of saying add -2, I'm just going to say subtract 2. And if we're thinking about the blue area, we are wanting the stuff that is down of that line. And if we're heading down a line, that means we're looking for the stuff which is less. So y is less than -2x, take away 2, is the blue area. Okay, and for this video anyway, that's as far as I'm going to take it. Okay, I'm not going to take it any further than that. I think there's enough to think about there. Knowing your equation is so important. If you can't remember what the equation is, then you're probably not going to be able to get started with this. You have to know what the equation of a straight line is, and you have to know how to calculate a gradient. And you do those two things, you give yourself a fighting chance. Okay? And I'm going to leave that one there. There will be stuff to practice combined with this video. And if you feel like jumping straight into the next thing where things start to get a little bit more difficult, then you can watch the part 2 for this, which is coming out almost immediately afterwards. And yeah, I will see you in that one, hopefully.